A pharmaceutical company is researching a new anti-anxiety drug. Marketing the new drug is costly, and so the company only makes a profit if the drug would be effective for at least 80% of patients. The sample of 60 participants in a drug study showed that 52 responded to the drug, and we want to know if the company should market the drug. We're interested here in the proportion of people that the drug would be effective for, and we want to know if that would be at least 80%. So in doing our hypothesis test, we're going to use a null hypothesis that checks if p is equal to 0.8, because we always use an equal to sign in our null. And the alternative, what we're really interested in finding out, is if p is greater than 0.8, where p is the population proportion of people who take the drug. Our sample information is that we have 52 out of 60 that responded, so we can write our p-hat as 0.867. So our test statistic is our sample proportion, 0.867, minus the value we're testing for, which is 0.8, over the square root of 0.8 times 1 minus 0.8 divided by the sample size, which here is 60. So we get a test statistic of 1.30. To find how much evidence we have in favor of or against the null, we need to find our p-value. And since we're doing a greater than, we're looking at the probability of being greater than our test statistic for our p-value. So it's the shaded region here. So our p-value is equal to the probability that a standard normal z is greater than 1.30, which can be written as the probability that z is less than negative 1.30 for purposes of getting this value from our table. So if we go to our normal table and look for negative 1.30, we will get our p-value, and what we find is that our probability is 0.0968. That's bigger than a 5% level. There's not a level stated here, but if not stated, we use 5%. So with our p-value greater than alpha level of 0.05, we are going to fail to reject. So here we do not have significant evidence that the population proportion of patients for which the drug is effective is greater than 80%. To answer the question, then, they would not want to market the drug. One last point here is that you always want to check the conditions required for your test to be valid, and that is if n times p0 and n times 1 minus p0 are at least 10 for these one sample proportion problems. We have a sample size of 60, and our test value p0 is 0.8. And so if you check both of these, 60 times 0.8 is 48, and 60 times 0.2 is 12. These are both greater than or equal to 10, and so the test that we have looked at is a valid test.